We're going to look at finding the derivative using the product rule and the quotient rule. So our product rule, that's when we're multiplying two things together. So it's something with an x times something else with an x in it. Okay. To do the derivative, so the first part will be our f of x, the second part will be our g of x. Okay. So we leave the first part the same times the derivative of the second part. Then we're going to add the derivative of the first part plus we're going to leave the second part the same. So let's look at a couple examples. So find the derivative using the product rule. Okay, and we're using the product rule because I've got something with an x times something else with an x. So we are going to make this first part our f of x, and we're going to make the second part our g of x. Okay, so then our product rule, remember, it goes f times g prime plus f prime times g. So I'm just going to list out what these are. So for f, I'm picking 3x squared. Okay. Then f prime, that means the derivative. So the derivative of 3x squared, that's just power rule. So that'll be 6x. Then for g, that's the second part. So that's cosine of x. And then g prime, that would be the derivative. So the derivative of cosine is negative sine of x. Okay, so to find the derivative of this function, we're going to say f prime of x for this f of x. Okay, is going to equal f, so 3x squared, times g prime, so that would be a negative sign, then plus f prime, so the derivative of f prime, or of f was 6x, times g, which was cosine of x. And then all we do from here is just simplify. So we have 3x squared times negative sine of x, so that'll be negative 3x squared sine. So you always want to multiply the coefficients, and always put the regular x first, the trig part second. And then this second part would be 6x cosine of x. And then what you can do from here is take out your GCF. So I'm going to go one step more and factor out a negative 3x. Okay, I can't take out a trig function because they're different. So what that's going to leave me with is an x here times sine of x. Then from the 6, if I take out a negative 3, 6 divided by negative 3 is going to be negative 2. That x is gone. And I'm still left with cosine of x. So that right there will be our derivative. Let's look at another example. So this time I have two trig functions. So I have y equals 4x times sine of x. Okay, and again, we know it's product rule because I have something with an x, so I'm going to call that f, and something else with an x, and I'm multiplying the two of them together. So I'm just going to list out what my f prime, g prime is. So f is going to be 4 cosine of x. So if there's a coefficient when you're doing the product rule, you always want to include it with the first one. So you're always going to include it with your f. And then f prime, that would be the derivative of this. So the derivative of cosine is negative sine. So that'll be negative 4 sine of x. Then for g, we're using sine of x. So then the derivative of sine of x is just cosine of x. Okay. Then I can take this and use it for our product rule here. Okay. So we've got f, which is 4 cosine of x, so this will be y prime, our derivative. So f is 4 cosine of x times g prime, which is sine. Then plus, sorry, our g prime is not sine. Our g prime is cosine. Then plus f prime is negative 4 sine of x times g, which is sine of x. So now to simplify this, since these are the same, we can multiply these together. Cosine times another cosine is going to be cosine squared. Same thing with the sines. Sine times another sine is going to be sine squared. So that'll be 4 cosine squared of x minus 4 sine squared of x. And then we can go one step farther and factor out our GCF, which is just a 4 in this case. And that's our derivative using the product rule. Now let's look at a couple with quotient rule. So quotient rule is when you're dividing two functions. So whatever function is on top will be f of x. Whatever function is on the bottom will be g of x. Okay, so on the top we do g of x times the derivative of f minus the derivative of g times f all over g squared. So this one, find the derivative using the quotient rule. Okay, so I know I have to use the quotient rule because I have something with an x on top divided by something with an x on the bottom. And there's no way to combine these two and reduce it to not be a fraction. So the top will always be f, the bottom will always be g. Okay, and then we're just going to use our g times f prime minus g prime times f all over g squared. So for f, we're using the top 2 sine of x. So then f prime, the derivative of that, derivative of sine is cosine. So that'll just be 2 cosine of x. Then g is always going to be the denominator, so that'll be x squared. Then g prime, so the derivative, this would just be power rule, so bring the 2 in front, subtract 1. So that'll be 2x. Then I can just go sub all that in here and simplify for the derivative. So we've got g, which is x squared, times f prime, which is 2 cosine of x, minus g prime, which is 2x, times f, which is 2 sine of x, all over g squared. So that would be x squared squared. And then from here we will just simplify until we can't anymore. So the top, that'll be 2x squared cosine of x. So you always want to multiply the coefficients, so that'd be 1 times 2. Those always go first. Then the regular x goes next. The trig function will always go last. And then we've got minus 2x times 2, so that will be 4x sine of x. And then all over x squared squared. When it's a power to a power, you multiply those exponents. Then on the top, I can take out a 2x, and I'm left with x cosine of x minus, I'll be left with just a 2 since I factored out the x. And on this one, once we take out the GCF, we're going to be able to simplify more. Okay? So I can reduce these x's right here. I can cancel this x with one of these. So my final answer for the derivative, and it always needs to be fully reduced, so that's why we want to cancel those x's, will be 2 times x cosine of x minus 2 sine of x all over x cubed. Now let's look at one more with the quotient rule. Okay, so this time we have to use the quotient rule because I have something on top divided by something with an x on bottom. So something with an x on top with something with an x on the bottom. And you need the bottom to have more, like 2 terms if it's just x's. Like on this last one, there was a trig function on top. That's why we had to use the quotient rule. So if you have a fraction with a trig function anywhere, you're going to have to use the quotient rule. If you have a fraction with at least two parts on the bottom, so two terms, you're also going to have to use the quotient rule. So I've got my f is going to be x squared minus 2. So my f prime will be derivative of x squared is just 2x. The derivative of 2 is just 0. And then g is the denominator. So that'll be x squared plus 1. And then the derivative of that will just be 2x. And then again, we're just going to our g times f prime minus g prime times f all over g squared. So our derivative here will be g, so that's x squared plus 1, put it in parentheses because it has two terms to it, times f prime, which is 2x, minus g prime times f, so x squared minus 2, again put it in parentheses because it's two terms and we're going to have to distribute that negative 2x, all over x squared plus 1 squared. So on this one we want to distribute the 2x, so that will be 2x cubed plus 2x, and then on the second part I need to distribute the negative 2x. So that'll be a minus 2x cubed plus 4x. And on the bottom, you do not need to FOIL anything out. You only need to square it if it's just one term, like the last one. So on this one, you can leave it as x plus 1 squared. Then the last thing I need to do is just combine like terms. So these will cancel, and then I can add the x's together. So 2x plus 4x will be 6x, all over x squared plus 1 squared.